Sodium hydroxide. You've probably never bought it on purpose, but you've definitely used products that rely on it. From making paper and soap to refining petroleum, it's everywhere. And yes, it's also called caustic soda because it will happily burn through skin, eyes, and most of your bad decisions if you're careless. Today, we'll break down exactly how it's made in the Kastner-Kellner cell, step by step. Sodium hydroxide is one of the most versatile industrial chemicals on Earth. Its strong alkalinity makes it a key ingredient in cleaning agents, water treatment, textiles, and countless manufacturing processes. But that strength is also why it's dangerous. Even a small amount on bare skin can cause serious chemical burns. That's why its production requires carefully controlled systems. One of the most important industrial methods to make NaOH is the Kastner-Kellner process. The Kastner-Kellner cell has two main sections, an upper rectangular tank and a lower pipe-like portion. In the upper section you'll find titanium blocks submerged in concentrated sodium chloride brine. In the lower section there's mercury, circulating constantly with the help of a pump. This mercury serves as the cathode, while a graphite chamber called a denuder separates sodium from its mercury amalgam. The magic begins when electricity is passed through the brine. Positively charged sodium ions and negatively charged chloride ions migrate toward their respective electrodes. At the titanium anode, chloride ions lose electrons and form chlorine gas, 2Cl or Cl2 plus 2E. This chlorine is collected separately as a pure byproduct. At the mercury cathode, sodium ions gain electrons, 2Na plus 2E das 2Na. But pure sodium is highly reactive. It immediately combines with mercury to form an amalgam. The sodium amalgam is pumped into the denuder. Here it comes into contact with water and reacts 2NaHg plus 2H2O, 2NaOH plus H2 plus 2Hg. This reaction produces sodium hydroxide in solution and releases hydrogen gas. The mercury is recovered and recycled right back into the cell for continuous production. Why use this method? It keeps chlorine gas and sodium hydroxide completely separate during production, preventing unwanted side reactions while allowing continuous high-purity production. The drawback? Mercury. Even with tight controls, small amounts of mercury vapor can escape into the environment. Mercury contaminates water systems, accumulates in marine life, and moves up the food chain, eventually ending up in the very humans who built the process. The Kastner-Kellner process remains important for producing sodium hydroxide, but environmental concerns are pushing industry toward greener, mercury-free alternatives. Still, this process is a fascinating example of electrochemistry at industrial scale.